Welcome to AA1-8. We're solving radical equations today. Just a heads up on this one, there are some parts to this where if you struggled with quadratics, that was back in 1.5, I would definitely recommend rewatching that video or watching it for the first time, because especially at the AB level for some of these problems, you do need to be comfortable with solving quadratics. Okay, so first off, radicals. Radical is the same thing as a square root. So when we are talking about, for example, the square root of 36, what I'm looking for is what number multiplies by itself to get 36. And that number would be 6 times 6 gives us 36. Now, there was some discussion a while ago when we were solving radicals, where if we had x squared equals 36, sorry, not solving radicals, but solving quadratics, we would square root both sides, and we would have a positive or negative version. The reason for that is that back to our original, if I have 6 squared, that gives me 36. If I have negative 6 squared, that also gives me 36. What I don't want you to get confused on with this is if I'm solving for x squared, if I'm solving a quadratic and I take the square root to solve, my answer is going to be positive or negative. But if I am taking the square root of just a number, my answer is always positive. So that can be a little bit confusing. So let's talk about it on the next one. So here we are on this one. This is just from the investigation we did in class. So if I have x squared equals 9, take the square root of both sides to solve. And technically we want to have a little plus or minus here and here. And then we have x is positive or negative 3, because if I go back to my original equation, 3 squared would give me 9, or negative 3 squared would give me 9. On the next one over, if I square root both sides, I can't take the square root of a negative number, because anything multiplied by itself will give me a positive. So this one has no real solution. We'll get to a point somewhere where we're going to deal with those non-real solutions. But for now, if we have something squared equaling a negative, doesn't have a solution. So now we're going to get into this part today where we're in radical form or square root form. So the square root of x equals 3. So to undo that, we square both sides. So then we have x equals 9. So when I refer to, I may refer to it a couple times, inverse operations, I am looking at like positive and a negative. If I'm adding, subtracting, we'll undo that operation. That's an inverse operation. If I multiply, division is how I undo it, and vice versa. So today what we're dealing with is if I have something squared, a square root is going to undo that, and vice versa. So if I have a square root, then squaring both sides will take care of that. So just wanted to give you a heads up on that in case you were not familiar with that already. And then so this last one though, if I have the square root of x equals negative 3, we have no solution on that. So this positive and negative solution and this part, people have trouble squaring both of those or understanding both of those things in their head. So make sure you understand if you're taking the square root to solve for x squared, you have a positive and negative solution, because both of those will work. I don't know why my pen's all glitchy, sorry. Both the positive and negative 3 will work in the original equation. Back here, if I have the square root of a number, it's always going to be a positive number. That's just one of those math things. Okay, so now if I'm looking at this, I have 3 equations that will not have a real solution and 3 equations that will have one solution. So this is very similar to the stuff we did with absolute value. We want to watch those negatives. So if I have this first one here, square root of x equals 8, that's a square root equaling a positive. That's going to have one solution. If I go to my next one, square root of x equals negative 4, the square root equals a negative, that is not going to have a solution. Next one. Here, just like I did with my absolute value, I need to get the radical alone. So I've got the square root of x equals 5. It's a positive number. That is going to have a real solution, so I'm going to put a box around that one. Next one, x squared equals 14. I would square root both sides. That one, different kind of an equation, but that would have, that one would actually have two solutions. So I have neither a box nor a circle around that one. Whoops. Next one, next row, square root of x minus 4 equals negative 1. Square root is, or the radical is isolated, equaling a negative. That one's not going to have a solution. So I didn't circle that one. Next one over, x squared equals a negative. Anytime you square something, it's always going to come out positive. That one will also not have a solution. I need to do some erasing here. Square root of x minus 4 equals 1. That will have one solution because it's a square root equaling a positive. And the last one, if I add 9 to both sides, I have x squared equals 4. That one is going to have two solutions because when I square root both sides, it's a really bad square root, I got x equals positive or negative 2. All right, so it will not have a solution if your square root equals a negative. It will have one solution if your square root equals a positive. Or for that matter, 0. And it will have two solutions if you're using a square root to solve an x squared. Okay, moving on. Let's go ahead and go over these. If I were you, I would pause the video and attempt to solve these on your own, but that's your call. I'm going to zoom in on this a little bit. Okay. So on the first one, part A, I'm going to add 4 to both sides. I have radical x, or square root of x, equals a positive 3. I'm going to square both sides to get rid of that x. So I have x equals 9. You want to be careful on checking at this step right here. Once it's isolated, you want to make sure that's a positive, because if you square both sides, you'll undo the negative, and then you make a mistake and you don't catch it. Part B, I need to isolate that radical, so I've got divide by 2, so I have rad x equals 3. Once again, equals a positive, square both sides, I have x equals 9. All right, let's move this over. Okay, I think that's what I'm intending to do. We'll see what that looks like on the video. Hopefully it's okay. Subtract 7 from both sides. 3 times the square root of x equals 25 minus 7 is 18. Divide both sides by 3 to get that rad x, or radical x, square root of x, however you want to say it, alone. So square root of x equals 6. I'm going to square both sides, and I have x equals 36. Part D, once again, I need to take away that 1. So I've got 2 times the square root of x minus 2. Make sure anytime you have more than just x under that square root, you're really clear about where this line ends. Some people tend to expand it, some people tend to make it too short, and it's not totally clear that that entire x plus 2 is underneath that square root sign. So that equals 10. I'm going to divide both sides by 2. So the square root of x minus 2 equals 5. Now I'm going to square both sides. Just as it was with the absolute value, what's in this part right here, you want to think of it as its own thing. Like this is its own thing. So squaring it really just undoes, however grammatically correct that is, the square root sign. So what I'm left with is x minus 2 equals 25. I want to take one more step there, add 2 to both sides, so x equals 27. All right, let's come back to those. Sorry for all the ins and outs. And we'll move into a more complicated example and write down some steps. I would definitely recommend writing this in your notes. Okay. So our first step, just as it was with absolute value, you're going to isolate the radical. So over here, I need to subtract 3 from both sides of the equal sign. I'm going to go ahead and make my line down the middle so I know not to cross that. That adds out to 0, so I'm left with 2 times the square root of x minus 4 equals 2x minus 12. Negative 9 minus 3 gives us that negative 12. The next step in that isolating process, I need to get rid of that 2. So I'm going to divide both sides by 2. Remember, when you divide by 2, you're dividing everything by 2. When you're adding or subtracting, you just do it once to each side. But when you're multiplying or dividing, it's to everything. So on the left side, I have square root of x minus 4 equals, my 2's divide out, so I'm just left with x there. And then negative 12 over 2 gives us negative 6, so that's x minus 6. Once I have the radical isolated, my next step is to square both sides. And I'm going to make a note about this in just a second. So I want to, I'm going to put a line there. Okay. Squaring both sides of this equation. Take x, square root of x minus 4, square it, equals, and I'm putting that parentheses around that x minus 6 because I have to square that whole thing. And when I do that, the x minus 6, it's very important to remember the exponent tells us how many times to multiply this whole thing by itself. You can't distribute it like you would a coefficient out front. So what I have here is actually not what I wanted to write that in. X minus 6 times x minus 6. So when I multiply that out, that's x squared minus 6x minus 6x plus 36. And this is where the things I need about radicals start to come into play. So my simplified version now on this side is x squared minus 12x plus 36. And on the other side, on the left side, those two things are inverse operations, so I'm left with x minus 4. Okay, a few adjustments to make, so I want to extend that a little bit further. Now, when you square both sides, you may have a pretty simple process, but in this particular case, that is not what happens. So when I go to step 3 here, I want to note that this is not with all equations. If I have, so I'll put that, if you have x's and x squareds, you need to treat it like a quadratic. And what I mean by that is the stuff from 1.5. So if we think back, and I don't want to write all the steps here because that's a little bit obnoxious. If we go back to 1.5, what we find is that when we have x's and x squareds, we have to get everything to one side of the equal sign equaling 0. So I need to get rid of this x and the -4 and get those to the other side. So I'm going to subtract x. I'm going to add 4 to get 0 equals x squared minus 13x plus 40. All right, so when I do that, my two options here, okay, brief interruption, so I apologize if I repeat anything. Hopefully I don't skip anything here. So now I have here a full quadratic. As I said before, not every problem like this is going to come down to a full quadratic, but we have two methods so far of solving these, and one of them is factoring and zero product property, and the other is the quadratic formula. I'm going to go ahead and factor just because a few people are a little less familiar with that and will need that skill eventually. So this is kind of the long way around for this, and there are quicker ways to do it, but I'm just showing you the process a few times. So we start with our first term, lower corner, last term, in the upper corner. And we take those two terms and we multiply them. So we get 40x squared. Take our middle term, negative 13x, and we put it on the bottom. Now what we need are two terms on the side here that multiply to give us our top number 40 and add to give us our bottom number. I'm not going to worry about the negatives right at the moment. I'm just going to factor 40. So I have 1 and 40. 40 divided by 2 is 20. 40 divided by 3 is not a whole number, so I'm not going to list it. 40 divided by 4 is 10. 40 divided by 5 is 8. 40 is not divisible by 6 or 7. So then I'm back to 8 and 5, which tells me I have all the factors I need because these repeat. Okay, so now I'm going to look at the negatives. They multiply to give me a positive, which means they're either both negative or both positive. Since the bottom number is negative, that means they're both negative because you can't have positive numbers adding up to be a negative number. So I'm going to go ahead and add my negatives to all of my numbers. And the pair that works, if I add negative 1 and negative 40, it's negative 41. Negative 2 and negative 20, negative 22. Negative 14. Right here, negative 5 minus 8 is negative 13. That's the pair that I want. Negative 5x and negative 8x. I'm going to stick those two in here. And then I'm going to factor. Now, when your a value is 1, so 1x squared, not in a different number, you don't have to think too hard about this. The only thing that's going to multiply together to give you x squared is x times x. X times negative 8 gives you negative 8x. X times negative 5 gives you negative 5x. Then you just need to double check that this term, negative 5 times negative 8, gives you a positive 40. You're good to go, and you are in factored form. So 0 equals x minus 8 times x minus 5. And then you use zero product property, set both of those equal to 0. X minus 8 equals 0, x minus 5 equals 0. Add 8. So one of our answers is x equals 8. Make that a more minus. Add 5, whoops. Add 5. So x equals 5. So I have two possible answers here. And I say possible because, I'm going to zoom way out for a second. My original problem up here, get rid of that, has x's on both sides. And just like the absolute value, when I've got x's on both sides, I need to check my answers. So I need to, whoops, too much, I'm gonna pause. Okay, now that I fixed that. So the last step, I forgot what step we were on, step 4, is to check for extraneous solutions in your original equation. So my two solutions, 8 and 5, I'm going to check those separately. So first off, got x equals 8. So 2 times the square root of 8 minus 4 plus 3 equals 2 times 8 minus 9. So I took my 8 and I put it in here and here. And then I just need to evaluate. Don't use your solving steps here because you will square things and you won't catch extraneous solutions. So I've got 2 times the square root of 8 minus 4 is 4. Drop down the 3. 2 times 8 is 16 minus 9. 2 square root of 4 is 2. So once I take the square root, I can get rid of that square root sign. Plus 3. 16 minus 9 is 7. Sorry. 2 times 2 is 4. Drop down the plus 3. And 4 plus 3 is indeed 7. So we are good to go. 8 is one of our solid answers. Just pop this over and we'll check the 5. So checking the x equals 5, we do the same thing. 2 times the square root of 5 minus 4 plus 3 equals 2 times 5 minus 9. So I've got 2 times the square root of 1 plus 3 equals 10 minus 9. Just did that. Multiplied those two. 2 times 1 plus 3 equals 10 minus 1 is just 9. So 2 plus 3 equals 1. So 5 equals 1. That is not true. That doesn't work out. The reason that doesn't work out, what it comes down to here, is when we square things to solve, we have two answers. Or sorry, we just have the one answer. This wants to give us two answers. So we didn't make a mistake here. Everything is good. 5 is an extraneous solution. So anytime, again, you have x's on both sides, you need to make sure to check for those extraneous solutions. I'm going to shrink this way, way down so you can see all those together. And also note that right here, if you have trouble with that one, see AA1-8 for solving quadratics. And that will help you with those. Again, that is going to be AB level. So if you're just going for a C, that's not necessary. You're going to have some simpler solutions. But and that is it for today's stuff. Hope that helps and have a lovely day. Bye.